Hello, the name of this work is Feature Extraction and Classification of Power Quality Disturbances based on FFT and ANN. This presentation's content consists of 6 titles. These titles are Introduction, Feature Extraction Method based on FFT, Classifying of PQD based on ANN, Results, Conclusion and References. In recent years, power quality issue is the subject of much research for increasing number of electronic and power electronic equipment components, non-linear loads, unbalanced power systems, solid-state switching devices used in industrial and public sectors. Therefore, power quality disturbances detection and classification is extremely important for protection of power distributed network. Various approaches for detection and classification of PQD are developed in literature. Number of papers based on different techniques such as Fourier transform, wavelet transform, S-transform, Hilbert-Hung transform, Gabor-Wigner transform, Kalman filter, and several intelligent classifiers such as artificial neural network, fuzzy logic controllers, support vector machines, rule-based systems are used for classification and recognition of PQD. This work aims to detection and classification of PQD based on FFT for disturbance identification and ANN techniques for classifying of these disturbances. In this study, 6 voltage waveforms including persine, voltage seg, voltage swell, flicker, transient, and voltage with harmonic are produced by using mathematical model in MATLAB. TSAN 50160 standard is used as a reference for feature extraction based on FFT. The parametric equation for the generated signal are shown in table. Healthy simulation model operates at 1 per unit voltage amplitude. Sampling frequency is 25.6 kHz. PQD are produced as 5120 samples in temporeous lengths. The frequency component of the signals are generated by using FFT analysis. The amplitude of the coefficients obtained from the FFT transform can be seen in the power spectrum graph visually. The PC of a signal shows how a power of signal is distributed through the frequency domain. The persine and its PC graph is given in figure A. One of the voltage seg samples and its PC graph is given in figure B, and voltage swell samples and its PC graph is given in figure C. Voltage seg and voltage swell signals contains 50 Hz frequency component. Therefore, there is a decrease in the component corresponding to 50 Hz for voltage seg signal, while an increase in voltage swell signal. The flicker signal given in figure D is generated by adding 5860 Hz component on a 50 Hz component. This frequency range is chosen because the best distinguished flicker frequency by the human eye is between 8 and 10 Hz. The frequency ranges are shown in the PC graph. One of the transient signal samples and its PC graph is given in figure E. In transient signal, a 4 kHz transient is generated and an increase in coefficient corresponding to 4 kHz component is observed. Figure F gives the voltage with signal obtained by adding third and fifth harmonic component on the 50 Hz fundamental frequency component. It's seen in the PCO harmonic signal that an increase in the component coefficients corresponding to third and fifth harmonic is observed. Database with 480 PQD waveform is generated with 80 samples for each of the 6 types of the waveform with randomly different disturbances amplitude, beginning occurrence time, time duration, frequency component, and angle according to type of disturbance. FFT is used to extract features of the disturbances by decomposing the signal. Then 16,384 times 480 data are reduced to 480 times 480 data by applying principal component analysis. The proposed NN architecture is selected from MATLAB Neural Network Toolbox. As seen in figure, two-layer feed-forward network with a hyperbolic tangent sigmoid transfer function is hidden layer, and softmax transfer function in the output layer are used as a classifier. The number of input is 480. The hidden layer has 10 nodes while the output layer has 6 nodes. PQD that are classified is given in table. From 480 PQD, 336 PQD are used for training cluster, 72 for validation, and the remaining 72 for testing the ANN classifier. It is shown in that figure that there is a perfect hug in or OC curves on the left and top edge, and this test indicates that the ability of discrimination is excellent. And as seen in this figure, the 99.8% recognition performance showed that the training performs well. ANN was trained with 100% accuracy and tested with 100 accuracy. This ratio is thought to be very successful and sensitive. A system for recognition and classification of PQD by using FFT and ANN is presented in this paper. The proposed system is capable of recognition of various PQD with 100% accuracy. It is also shown that the overall accuracy is 90.8%. FFT, which is used for feature extraction in this paper, can classify the PQD problems. Feature extraction and classification of PQD based on FFT and ANN gives satisfactory results. In the next study, it will be shown the performance of the method by using real-time data. Thank you.